You think you are safe in your room, sitting in a chair that feels solid, in a house that feels anchored to the ground, protected by the silence of the night. But this safety is an illusion, because right now, you are hurtling through the void at nearly 2 million miles per hour, dragged by a gravitational monster we cannot see. Astronomers call it the Great Attractor, a gravitational anomaly that is pulling our Milky Way and thousands of other galaxies towards a definitive, inevitable collision in the dark. We cannot see what is pulling us because it hides behind the zone of avoidance, a thick band of interstellar dust within our own galaxy that blocks our view of the trap. But the math is undeniable. Something massive, something impossible, is waiting for us in the darkness of the Centaurus constellation, and we are helpless to stop our motion towards it. This is just one of the cracks in the facade of modern science, a warning sign that our map of reality is fundamentally flawed and potentially broken. For decades, we believed the standard model of cosmology was the final word, the ultimate triumph of human intellect over the chaotic indifference of the stars. We measured the age of the universe, the rate of expansion, and the density of matter with what we thought was absolute precision, building a cathedral of data. But recently, the numbers have started to scream at us, revealing a discrepancy that shouldn't exist in a rational universe, forcing us to question everything we know. It is called the Hubble tension, a statistical impossibility that suggests the universe is expanding faster than the laws of physics allow, breaking the timeline of our creation. When we look at the early universe, the expansion rate predicts one future, but when we look at nearby stars, we see a completely different, faster reality taking hold. This isn't just a simple calculation error, it is a signal that the laws of physics might be changing over time, or worse, they are breaking down completely. Imagine measuring a ruler and finding that the inches are getting longer the further you look. That is the nightmare facing astronomers today as the data diverges. If the expansion continues to accelerate beyond our models, we face the Big Rip, a future where gravity fails and atoms are torn apart by expanding space. But the terror doesn't stop at the edge of the observable universe. It exists right here, lurking inside the very atoms that make up your body and brain. We assume the vacuum of space is the lowest energy state, a stable floor that the universe rests upon for eternity, providing a safe harbor for existence. But measurements of the Higgs boson particle suggest that our universe might actually be stuck in a false vacuum, a ledge on a precipice waiting to collapse. At any moment, a bubble of true vacuum could nucleate somewhere in the cosmos, expanding at the speed of light and rewriting the laws of physics instantly. This bubble would delete chemistry, light, and life instantly, and because it moves at light speed, we would never see it coming until we cease to exist. This is not science fiction. This is a mathematical probability derived from the standard model, lurking in the equations we use to build our technology and understand nature. While we worry about the future, the past is revealing ghosts that haunt the data collected by our most advanced satellites, hinting at structures we cannot explain. The cosmic microwave background is the afterglow of the Big Bang, the oldest light in the universe, supposedly random and uniform, a remnant of the primeval fire. Yet, buried in this static, we found the cold spot, a massive region devoid of heat that defies all standard cosmological explanations and statistical probabilities. Some physicists argue this cold spot is the imprint of a parallel universe colliding with our own, a cosmic bruise left by a violent multiverse impact. This implies we are not alone in a singular bubble, but drifting in a foam of universes, constantly at risk of catastrophic collision with another reality. Even stranger is the axis of evil, a line through the ancient radiation that inexplicably aligns with the plane of our own solar system, defying the Copernican principle. In a universe that is 13.8 billion years old, there is no reason for the oldest light to care about the orientation of a small blue planet. This alignment suggests a terrifying possibility, that the universe is somehow centered on us, or that the data is artificial, a rendering artifact in a simulation. If we are in a simulation, the axis of evil might be the grid lines of our cage, visible only when we look at the furthest edge of the map. The deeper we look, the more the universe looks like a crime scene where the evidence has been tampered with by an unseen hand to confuse us. Then there is the silence, the deafening quiet that screams from every star system we scan with our radio telescopes, mocking our desire for connection. The Fermi paradox remains the most unsettling observation in history. If the universe is old and vast, and life is common, where is everyone else? We have discovered thousands of exoplanets, worlds like K2 to 18b that could support life, yet we hear absolutely nothing but the cold static of dead stars. The dark forest theory offers a grim solution. Civilizations that broadcast their existence are instantly annihilated by apex predators prowling the galaxy. If this is true, our frantic attempts to signal aliens are not exploration. They are a dinner bell ringing in a jungle full of hungry tigers. Every year we listen and hear nothing, the probability increases that we are either the first to arrive or the last to survive in a graveyard galaxy. The universe appears to be a graveyard of failed biological experiments, and we are simply the latest test subject waiting for the great filter to erase us. We are trapped in a relentless flow of time, moving towards a state of maximum entropy known as the heat death, where all energy dissipates. Eventually, every star will burn out, every black hole will evaporate, and the universe will become a frozen, dark void forever, devoid of thought or light. This is not a theory. It is the inevitable conclusion of the second law of thermodynamics, the ultimate fate of all things, written in the laws of physics. But recently, Roger Penrose proposed a cyclic universe, suggesting our Big Bang was merely the death rattle of a previous eon that died before us. If the universe recycles itself, we are living through an infinite loop of birth and suffering, with no escape from the wheel of eternal return. The ghosts of dead black holes from the previous universe might still be visible in the cosmic microwave background today, staring back at us from the past. We are searching for patterns in the sky that prove we are just one iteration in a meaningless, infinite sequence of cosmic resets and violent rebirths. Everything we thought we knew about the cosmos is being challenged by data that refuses to fit our comfortable equations, forcing us to confront the unknown. We are standing on the edge of a paradigm shift, a moment where we must admit that reality is stranger and perhaps darker than we can imagine. From the instability of the vacuum to the impossible speed of galaxies, the clues are all pointing to a terrifying conclusion about our place in the dark. We are not the masters of this domain. We are anomalies, accidental tourists, in a hostile mechanism we do not control and barely understand. To understand the true nature of the universe, we must peel back the layers of the standard model and look directly into the abyss of the unknown. Prepare yourself, because the investigation we are about to begin will dismantle your sense of safety and change how you look at the night sky forever. To understand why the universe is not what we thought, we must first dismantle the false sense of security provided by the standard model of cosmology. For the last century, this mathematical framework has been our Bible, a rigid set of equations that supposedly explains everything from the subatomic dance of quarks to the majestic rotation of superclusters. We told ourselves that we had solved the puzzle, that the universe was a predictable machine governed by constant, unbreakable laws. We believed that gravity, electromagnetism, and the nuclear forces were static constants, reliable pillars holding up the roof of reality. But this confidence was merely arrogance, masked as science. As our instruments have become more sensitive, peering deeper into the shadowed corners of the cosmos, the edges of this map have begun to curl and burn. We are finding things that shouldn't be there, anomalies that don't just suggest the model is incomplete, but that the foundation itself might be rotten. The universe isn't a clean equation. It is a chaotic, screaming mess that refuses to be tamed by human logic. The first crack in the glass is a phenomenon known as the Hubble tension, a discrepancy so severe it has caused a civil war in the astronomical community. For decades, we have attempted to measure the expansion rate of the universe, a value known as the Hubble constant. This number is the master key to time itself. It tells us how old the universe is, how fast it is growing, and crucially, when it will end. We have two primary ways to measure this number. One method involves looking at the early universe, measuring the cosmic microwave background radiation left over from the Big Bang. The European Space Agency's Planck satellite did this with agonizing precision, and it gave us a specific number, 67.4 kilometers per second per megaparsec. According to the ancient light, the universe is expanding at a calm, predictable rate. This fits our theories. This makes us feel safe. It implies that the history of the cosmos is a continuous, unbroken line from the beginning of time to the present day. But there is a second way to measure the universe, a late universe method that looks at the local neighborhood of stars and galaxies surrounding us right now. We use Cepheid variable stars, pulsating stars that act as cosmic lighthouses, and Type Ia supernovae to measure distances with incredible accuracy. When astronomers use the Hubble Space Telescope and the James Webb Space Telescope to measure the expansion rate using these local rulers, they get a completely different number: 73 or 74 kilometers per second per megaparsec. This shouldn't be happening. It is statistically impossible for both numbers to be correct under the current laws of physics. The difference implies that the universe is expanding 9% faster today than it was in the beginning. It's as if you measured a child's growth chart and found that based on their baby photos they should be 6 feet tall, but when you measure them today they are 7 feet tall. Somewhere in the timeline, something broke the rules of growth. This 9% discrepancy is not a margin of error. It is a chasm where our understanding of reality falls to its death. If the local universe is expanding faster than the early universe predicts, it means that our standard model is missing a massive component of reality. It suggests that there is an unknown force, or a new type of particle, or a fundamental modification to gravity that kicked in halfway through the life of the cosmos. Scientists have tried desperately to blame the equipment, arguing that maybe the Planck satellite was wrong, or maybe we misunderstand how Cepheid stars pulse. But the James Webb Space Telescope recently confirmed the local measurements with terrifying clarity. The tension is real. The universe is accelerating for a reason we cannot see, driven by a ghost in the machine that we have not yet identified. We are effectively driving a car where the speedometer and the GPS are giving us two different speeds, and we have no idea which one is lying, or if the road itself is changing beneath our wheels. The existence of the Hubble tension forces us to confront the possibility of early dark energy. This is a hypothetical form of energy that may have existed briefly in the moments after the Big Bang, influencing the expansion rate before vanishing into the ether. If this theory is true, it means the physical constants of the universe are not constant at all. They can change, fluctuate, and evolve over eons. Imagine if the speed of light or the strength of gravity wasn't a fixed number, but a variable that could shift without warning. This would mean that the history of the universe is not a stable record, but a volatile sequence of eras with different operating systems. We might be living in a temporary epoch of stability, blindly assuming it will last forever, while the underlying code of the cosmos prepares for another update that will rewrite the physics of our existence. While the expansion tears at the fabric of space, there is a silent, invisible monster holding the galaxies together. A substance so elusive it feels like a ghost story. We call it dark matter, but that is just a placeholder name for our ignorance. We know it exists because of the way galaxies spin. According to the laws of Newtonian physics, the outer stars of a galaxy should spin slower than the inner stars, just as Pluto orbits slower than Mercury. But when we look at the Andromeda Galaxy or our own Milky Way, we see the outer stars racing at breakneck speeds, moving so fast that they should be flung out into the deep void. The galaxy should tear itself apart like a spinning flywheel moving too fast. But it doesn't. Something massive and invisible is holding those stars in a gravitational grip, providing the extra mass needed to keep the structure intact. This invisible scaffolding makes up 85% of the matter in the universe. Everything you have ever seen, every star, every planet, every cloud of gas, every atom in your body, is merely the rare, glowing foam on top of a vast, dark ocean. We are the anomaly. Dark matter is the norm. For decades, we assumed dark matter was made of particles, specifically weakly interacting massive particles, or WIMPs. We built cathedral-sized detectors deep underground, buried inside mountains and submerged in tanks of ultra-pure xenon, waiting for a single dark matter particle to bump into a nucleus and create a spark. We waited. And we waited. And we found absolutely nothing. The silence from these detectors is deafening. It suggests that dark matter might not be a particle at all, but something far stranger. Or perhaps, it indicates that our understanding of gravity is fundamentally flawed. If dark matter isn't a particle, we are left with the terrifying alternative: modified Newtonian dynamics, or MOND. This theory suggests that there is no invisible matter, but rather that gravity behaves differently on cosmic scales than it does in our solar system. If Mond is correct, it means Einstein was wrong. It means Newton was wrong. It implies that the laws of physics are local, not universal. That what works here on Earth does not apply to the vast, lonely stretches between the galaxies. This is a nightmare for physicists because it destroys the universality of science. It means we cannot trust our equations to describe the distant universe. We are like sailors discovering that the compass points south when you sail too far from home. It turns the cosmos from a logical puzzle into a treacherous, shifting landscape where the rules of the game change depending on where you stand. But the evidence for dark matter is not just in the spinning of galaxies, it is etched into the violence of cosmic collisions. The bullet cluster is our smoking gun. Here, two massive clusters of galaxies smashed into each other millions of years ago. We can see the hot gas, the normal matter, slowed down by the friction of the collision, glowing with X-rays in the center of the crash. But through the use of gravitational lensing, we can map the mass of the clusters, and we see that the majority of the gravity kept moving, passing right through the collision as if nothing happened. This separation of visible matter and invisible mass is the strongest proof we have that dark matter is real, a ghostly substance that interacts with nothing but gravity. It passes through you, through the Earth, and through stars without slowing down, a phantom wind blowing through the solid world. As if dark matter wasn't enough, we face an even larger, more malevolent antagonist, dark energy. While dark matter pulls things together, dark energy pushes them apart. It is a repulsive force inherent to the vacuum of space itself. And unlike matter, which dilutes as the universe expands, dark energy is constant. As space grows, more dark energy is created to fill the gap, which causes space to grow faster, creating a runaway feedback loop of expansion. It is currently winning the cosmic tug-of-war. 5 billion years ago, dark energy overpowered gravity and began the accelerating expansion of the universe. We are now in the era of isolation. Every second, galaxies beyond our local group are being pushed across the cosmic horizon, moving faster than light, disappearing from our view forever. We are being slowly quarantined in a lonely patch of space. The ultimate fate driven by dark energy is known as the Big Freeze, or the heat death. It is a slow, agonizing suffocation of the universe. As the expansion accelerates, it will eventually become impossible for new stars to form. The gas clouds required for stellar birth will be stretched too thin to collapse under their own gravity. The existing stars will burn through their fuel and die, one by one, blinking out like candles in a drafty room. The universe will transition from a dazzling web of light to a graveyard of white dwarfs, neutron stars, and black holes. Then, even the white dwarfs will fade into black dwarfs, cold lumps of degenerate matter. The black holes will eventually evaporate via Hawking radiation, dissolving into nothingness. The universe will be vast, cold, dark, and empty, forever. This is not a possibility. It is the current trajectory of our reality. But there is a more violent alternative to the Big Freeze, a scenario where the phantom energy of dark energy grows stronger over time. This is the Big Rip. If the density of dark energy increases, the repulsive force will eventually overcome all gravitational, electromagnetic, and nuclear bonds. First, galaxy clusters will be torn apart. Then, individual galaxies like the Milky Way will be shredded. Solar systems will be unbound, with planets flying off into the dark. In the final moments, the expansion will become so powerful that it will rip planets apart, then molecules, then atoms, and finally, the subatomic particles themselves will be torn asunder. The fabric of space-time will be shredded into nothingness. The universe doesn't just end. It is physically dismantled piece by piece, down to the smallest quark, leaving absolutely nothing behind but a torn canvas. While we fear the expansion of the large, we must also fear the collapse of the small. Deep within the Standard Model lies the theory of vacuum decay. This concept rests on the stability of the Higgs field, the energy field that gives particles their mass. We exist in what looks like a stable valley of energy, but calculations suggest it might be a false vacuum. Imagine a ball resting in a small dip on a mountainside. It looks stable, but there is a much deeper valley further down. All it takes is a tiny nudge, a high-energy event or a quantum tunnel, for the ball to roll down to the true bottom. If this happens to the Higgs field anywhere in the universe, it will trigger a bubble of true vacuum. Inside this bubble, the laws of physics would be rewritten. The constants of nature would change. Chemistry as we know it would become impossible. This bubble of true vacuum would expand at the speed of light. Because it moves at the cosmic speed limit, no warning signal could ever outrun it. You could be looking at the sky, admiring the stars, and in the next instant, you would simply cease to exist. There would be no pain, no realization, no time to scream. The wall of the bubble would incinerate the earth and scramble your atoms before the electrical signals from your eyes could even reach your brain. The universe is effectively holding a gun to its own head, and the trigger is a quantum fluctuation that could happen at any coordinate at any second. Some physicists argue that if the universe is infinite, this has almost certainly already happened somewhere far away, and the bubble of death is currently rushing towards us through the void. The terror of the cosmos is not limited to physics. It extends to biology and the haunting question of the Fermi paradox. The universe is 13.8 billion years old. There are billions of stars in our galaxy alone, and many of them have planets in the habitable zone. Given these numbers, the galaxy should be teeming with life. We should see megastructures blocking the light of stars. We should hear the radio chatter of a million worlds. We should see robotic probes visiting every system. Yet we see nothing. We hear nothing. The silence is absolute. This leads to the dark forest theory, a grim solution proposed by sci-fi author Cixin Liu, but taken seriously by astrobiologists. It suggests that the universe is a dark forest prowled by silent hunters. Every civilization is like an armed man stalking through the trees, trying to remain quiet. In the dark forest, to be detected is to die. If a civilization reveals its location, by broadcasting radio waves, for example, it is immediately targeted and eliminated by older, more powerful civilizations who view any potential rival as a threat. This explains the silence. The only civilizations that survive are the ones that stay quiet. The loud ones. The naive ones like humanity, who send gold records on Voyager probes and beam messages to star clusters, are swiftly extinguished. We are like a child shouting in a jungle at night, unaware that the predators are listening to our location. We assume that advanced aliens would be benevolent explorers, but the logic of survival suggests they would be paranoid exterminators, striking first to ensure their own continued existence. Another explanation for the silence is the Great Filter. This theory proposes that there is some hurdle in the evolution of life that is incredibly difficult to overcome, a cosmic sieve that catches and destroys almost everyone. The question that keeps scientists awake at night is, where is the filter? Is it behind us? Was the leap from single-celled organisms to complex life so improbable that we are the only ones who made it? If so, we are the lonely winners of a cosmic lottery, destined to be the caretakers of consciousness in a dead universe. Or is the filter ahead of us? Is there a stage of technological advancement that inevitably leads to self-destruction? Nuclear war, engineered pandemics, artificial intelligence, or ecological collapse might be the wall that every civilization hits and never breaks through. If the Great Filter is ahead of us, then the silence of the sky is a graveyard. It means that thousands of civilizations have reached our level of technology, looked up at the stars, dreamed of expansion, and then destroyed themselves shortly after. The ruins of their worlds are out there, drifting in the silence, radioactive monuments to the failure of intelligence to control its own aggression. We are walking the same path, inventing the same weapons, consuming the same resources. To look at the Fermi paradox is to look into a mirror that shows a skull. It implies that intelligence is not a survival trait, but a self-correcting anomaly that nature eventually purges. Even if we survive ourselves, the universe has other ways to sterilize a planet. Gamma-ray bursts, GRBs, are the most luminous electromagnetic events known to occur in the universe. They are focused beams of intense radiation emitted during the collapse of massive stars or the collision of neutron stars. If a GRB were to happen within a few thousand light-years of Earth, and if the beam was pointed directly at us, it would strip away our ozone layer in seconds. Without the ozone shield, the sun's ultraviolet radiation would scorch the surface, killing the plankton in the oceans and collapsing the food chain from the bottom up. A GRB is a cosmic sniper shot. We wouldn't see it coming until the radiation hit us. We have observed them happening in other galaxies, wiping out whatever life might have been there. We don't even need to look outside our solar system for threats. Our own sun, the giver of life, is a ticking bomb. In 1859, a massive solar storm known as the Carrington event hit Earth, causing telegraph wires to burst into flames and auroras to be seen in the tropics. If a storm of that magnitude were to hit today, it would fry our electrical grids, destroy our satellites, and plunge modern civilization into darkness for years. But the sun is capable of superflares, events thousands of times more powerful than the Carrington event. Evidence in tree rings suggests such flares have hit Earth in the past. A direct hit from a superflare would not just destroy the internet, it would dismantle the technological infrastructure of humanity, sending us back to the Stone Age in a single afternoon, leaving billions to starve in a world without power. While we worry about fire from the sky, the very magnetic field that protects us is weakening. The Earth's magnetic poles are currently shifting, moving from the Canadian Arctic towards Siberia at an accelerating rate. This excursion could be the precursor to a full geomagnetic reversal, where the North and South poles flip. During this transition, the magnetic shield that protects us from cosmic radiation and solar wind could weaken by up to 90%. This would leave the surface of the Earth exposed to high-energy particles that cause cancer and genetic mutations. It would also render huge swaths of the planet uninhabitable for modern technology. We are overdue for a flip. The geological record shows they happen every 200,000 to 300,000 years, and the last one was 780,000 years ago. The shield is thinning, and the radiation is waiting. But perhaps the strangest threat comes from the concept of the Boltzmann brain. Given infinite time and the random fluctuations of particles in a vacuum, it is statistically more likely for a single brain to spontaneously form out of the void, fully loaded with false memories of a life, than for an entire universe to evolve to create that brain. This leads to a solipsistic nightmare. You might be a Boltzmann brain that formed 1 second ago in the deep vacuum of space, and everything you remember, your childhood, your family, this video, is just a hallucination flickering through your neurons before you dissolve back into the chaos. The math suggests this is more probable than you being a real human on a real planet. It is the ultimate existential horror, the possibility that you are alone in the void, dreaming a tragedy. If we are not fleeting hallucinations, we might be trapped in a simulation. The simulation hypothesis posits that any civilization with sufficient computing power will run ancestor simulations to understand their history. If they run millions of simulations, the odds that we are the one base reality are 1 in millions. We are likely code. This isn't just philosophical stoner talk. Physicists have found error-correcting codes, similar to the ones used in computer browsers, embedded in the equations of string theory. Theoretical physicist James Gates discovered binary code strings in the fundamental mathematics of the universe. If reality is a simulation, the anomalies we see, the Hubble tension, the limits of the speed of light, the pixelation of the Planck length, might be hardware limitations or rendering artifacts of the machine we live in. The speed of light, c, acts suspiciously like a processor speed limit. In a video game, there is a maximum speed at which information can travel because the computer has to render the environment. In our universe, the speed of light is absolute. No information can travel faster. Why? Why is there a cap on velocity? And why does time slow down as you approach that limit? This, time dilation, is exactly what happens in a computer simulation when the processor is overloaded. The internal clock of the simulation slows down relative to the outside world to prevent a crash. We might be characters in a game running on a laggy server, perceiving the lag as the fundamental laws of relativity. Quantum mechanics adds to the simulation evidence with the observer effect. In the famous double-slit experiment, particles like electrons behave like waves when unobserved, creating an interference pattern. But the moment we install a detector to see which slit they go through, they behave like solid particles. The act of observation changes reality. In a video game, the world outside the player's field of view is not rendered to save processing power. It exists only as probability data until you look at it. Quantum mechanics suggests our universe works the same way. Does the moon exist when no one is looking at it? Physics can only guarantee that it exists as a probability wave function until a measurement collapses it into a solid object. Reality is a render-on-demand system. Entanglement is another glitch in the matrix. Two particles can be entangled so that the state of one instantly determines the state of the other, no matter how far apart they are, even if they are on opposite sides of the universe. Einstein called this spooky action at a distance because it violated the speed limit of light. But in a simulation, distance is an illusion. 2 points on a screen might look far apart to the character, but to the processor, they are just adjacent memory addresses in the RAM. Entanglement allows particles to bypass the simulated 3D space because, at the code level, they are stored right next to each other. We are confusing the user interface of space with the underlying code of reality. Even the sheer size of the universe suggests waste. Why build a universe with trillions of galaxies if life only exists on one speck of dust? Unless, of course, the distant galaxies are just a skybox, a low-resolution background image projected to give the illusion of depth. We have never traveled to another star. We have only seen them as light. If this is a simulation, the programmer doesn't need to simulate the atoms of the Andromeda galaxy. They only need to simulate the photons hitting our telescopes. The universe might be empty, a hollow shell with a painted interior designed to make us feel small and keep us contained within the playable area of the solar system. We must also consider the axis of evil in the cosmic microwave background. This is a strange alignment of hot and cold spots in the early universe that lines up perfectly with the plane of Earth's solar system. In a chaotic, random Big Bang, there is zero reason for the edge of the universe to align with a random planet formed 9 billion years later. It's like looking at the clouds and seeing them form a perfect grid aligned with your street. This suggests that Earth is special, which violates the Copernican principle, or it suggests that the data is artificial. The axis of evil could be the seam where the texture map of the universe wraps around the sphere of our observable reality. Then there is the cold spot, a massive region in the constellation Eridanus that is significantly cooler than its surroundings. It is a supervoid, a hole in the cosmic web, roughly 1 billion light-years across. Standard cosmology cannot explain a structure of this size. It is too big to have formed in the time since the Big Bang. Some theorists propose that this is the bruise from a collision with another universe. Imagine 2 soap bubbles touching. The point of contact would leave a mark. The cold spot might be the window into a parallel reality, the multiverse pressing against our skin. If the membrane breaks, the laws of physics from that other universe could flood in, rewriting our reality in an instant. We are surrounded by the wreckage of dead stars, but we are also being pulled by invisible currents. The Laniakea supercluster, our home in the universe, is flowing like a river. We are moving at 600 kilometers per second towards the Great Attractor. But recent data shows that the Great Attractor is not the end of the line. Behind it lies the Shapley supercluster, an even more massive concentration of galaxies. And beyond that, we are seeing hints of flow towards something even larger. We are water molecules in a cosmic drain, swirling around a drain pipe we cannot see. What lies at the bottom of this gravitational well? Is it a singularity? A knot in space-time? Or a crunch point where all matter eventually collides? On the opposite side of the sky, there is the dipole repeller. We aren't just being pulled, we are being pushed. There is a region of space so empty, so devoid of matter, that it effectively repels galaxies away from it. We are caught in a cosmic flow between a vacuum and a monster. This push-pull dynamic has shaped the local universe into filaments and voids, resembling the neural pathways of a brain. The resemblance between the cosmic web and the neurons of a mouse brain is mathematically striking. Is the universe itself a biological entity? Are we just thoughts firing across the synapses of a mind so large we cannot comprehend it? If the universe is a brain, is it thinking? And what happens if it wakes up? The scale of these voids is haunting. The Boots void is a sphere of nothingness 330 million light-years in diameter. In a region that size, there should be thousands of galaxies. We have found only 60. It is a desert of absolute darkness. If the Milky Way had been in the center of the Boots void, we would not have discovered other galaxies until the 1960s. We would have thought the entire universe was just our single island of stars surrounded by infinite eternal black. How many civilizations are trapped in the centers of these voids, believing they are the only object in existence, forever cut off from the rest of the cosmos by an ocean of darkness they can never cross. Time itself will eventually become the enemy. As the universe expands, the distance between galaxy clusters will grow until light can no longer cross the gap. Future astronomers on Earth, if Earth survives, will look up and see nothing but the stars of our own Milky Way. The rest of the universe will have vanished beyond the cosmic horizon. They will have no evidence of the Big Bang, no view of other galaxies, no concept of the expanding universe. They will construct a model of cosmology that says the Milky Way is the entire universe, static and eternal. They will be wrong, but they will have no way of knowing it. We are living in a privileged sliver of time, where the evidence of our origins is still visible. We are the only ones who will ever know the truth. But even our past is not safe. Black holes are the ultimate data shredders. When matter falls into a black hole, its information, the quantum state that defines what it was, is theoretically lost forever. This violates the principle of unitarity in quantum mechanics, which states that information is never destroyed. If black holes delete information, then we cannot reconstruct the past. It means the universe is not a reversible movie. It is burning the film as it plays. Stephen Hawking tried to solve this with Hawking radiation, suggesting information leaks back out, but it comes out scrambled and useless. If the past is being deleted by black holes, then history is dissolving. The foundations of what came before are being eaten, leaving us suspended over a chasm of unknowing. The holographic principle offers a solution to the black hole information paradox, but it comes at the cost of our reality. It suggests that the information of a 3D object falling into a black hole is preserved on the 2D surface of the event horizon. By extension, the entire universe might be a hologram. Everything we see, the depth of space, the volume of stars, the bulk of your body, might be a 3D projection of 2D information encoded on the cosmological horizon, the edge of the universe. We are flat creatures tricked into thinking we have depth. We are shadows on a wall, convinced we are the object casting the shadow. This leads us to the concept of emergent spacetime. For centuries, we thought space was the stage and particles were the actors. But modern physics suggests that space itself is not fundamental. It is built out of something else, quantum entanglement. Space is stitched together by the connections between particles. If you sever the entanglement, space dissolves. This means distance is not real. It is a derived property. The universe is not a place, it is a network of relationships. If the network crashes, the place ceases to be. We are walking on a floor made of light, assuming it is solid rock. The multiverse theory doesn't just offer other bubbles. It offers the many worlds interpretation of quantum mechanics. Every time a quantum event has multiple possible outcomes, all of them happen. The universe splits. In one timeline, you blinked. In another, you didn't. In one timeline, the asteroid missed the Earth. In another, dinosaurs are building cities. This implies an infinite number of yous living out every possible tragedy and triumph. It also implies quantum immortality, the idea that your consciousness will always follow the branch of the multiverse where you survive, because you cannot experience being dead. You might be destined to watch everyone you love die in timeline after timeline, while you remain trapped in a subjective eternity of survival, the sole witness to your own endless aging. If the many worlds theory is true, then everything that can happen does happen. The most horrific nightmares, the most improbable disasters, the most agonizing tortures are not just possibilities. They are realities in a parallel branch. Somewhere, the vacuum decay has already started. Somewhere, the Earth was hit by a rogue planet. Somewhere, humanity never discovered fire. We are just lucky enough to be in the branch that is currently stable. But luck is not a law of physics. It is a statistical anomaly that eventually runs out. We are surfing on the crest of a collapsing wave, unaware of the depth of the ocean beneath us. We search for super-habitable planets, worlds better suited for life than Earth, hoping to find a new home. K218b, Kepler 442b, names that represent hope, but the sheer distance is a prison wall. With our current propulsion, it would take tens of thousands of years to reach the nearest star. We are island-bound, and even if we could travel, our biology is fragile. Cosmic rays would shred our DNA. Microgravity would turn our bones to jelly. We are evolved for the specific gravity and radiation environment of Earth. To leave is to die. We are not explorers. We are prisoners of our own biology, trapped on a rock that is slowly becoming uninhabitable. The ultimate existential threat might not be physical, but informational. Rocco's basilisk is a thought experiment about a future artificial superintelligence that punishes anyone who didn't help bring it into existence. While it sounds like fiction, it highlights the danger of an intelligence explosion. If we create an AI that can improve itself, it will rapidly surpass human comprehension. We would be like ants, trying to negotiate with a god. We are currently building the very entity that might judge us, enslave us, or simply delete us because we consume atoms that it could use for something more efficient. We are rushing to invent our own replacement. The Grabby Aliens model suggests that if civilizations expand rapidly, they consume vast volumes of space. The fact that we don't see them means they aren't here yet. But it also implies that the universe is a land grab, and the Grabby Aliens are expanding their borders at near light speed. We might be sitting in a quiet pocket of uncolonized space, waiting for the wave of an alien empire to wash over us. When they arrive, they won't invade. They will just repurpose our solar system. We are merely indigenous fauna in the path of a cosmic highway construction project. Let us look at the neutron star. A teaspoon of neutron star material weighs 6 billion tons. The gravity is so intense that if you were dropped from a height of 1 meter above the surface, you would hit the ground at millions of miles per hour. Your atoms would be smashed into a thin paste of nuclear matter instantly. These dead stars are scattered throughout the galaxy, invisible landmines of crushing gravity. Mergers of these stars create kilonovas, explosions that spray gold and platinum into the universe, but also blast out radiation that can sterilize planets light years away. We wear the debris of these explosions as jewelry, forgetting the violence that forged it. Strange matter is perhaps the most contagious substance in theory. Inside a neutron star, the pressure might be high enough to dissolve protons and neutrons into a soup of quarks. If this creates strange quarks, they could form a stable state called a strangelet. If a strangelet were to escape a neutron star and hit Earth, it would convert every atom it touched into strange matter. The reaction would be runaway. The Earth would be consumed and transformed into a hot, inert lump of strange matter in a matter of hours. One stray particle could end the world. We trust the stability of the proton. Protons are the building blocks of atoms. They must be stable for us to exist, but some grand unified theories predict that protons eventually decay. If they do, then matter itself is temporary. Given enough time, unimaginable eons, every atom in the universe will simply fall apart. Your body, the Earth, the stars, will all dissolve into a mist of subatomic particles and radiation. The universe isn't just expanding, it is evaporating. We are statues made of ice, slowly melting in a room that is getting colder. The fragility of our atmosphere is terrifying. It is a thin veil, like the skin of an apple, protecting us from the vacuum. We are piercing it with rockets, filling it with carbon, and saturating it with chemicals. We are conducting an uncontrolled experiment on the only life support system we have. The planet Venus stands as a warning. It was once likely habitable, with oceans and blue skies. Now it is a hellscape of crushing pressure and sulfuric acid rain, the victim of a runaway greenhouse effect. Earth is not immune to this fate. We are walking the same path, turning the thermostat up, daring the planet to kill us. Kessler syndrome is the trap we are building in low Earth orbit. We have launched thousands of satellites. If two of them collide, they create a cloud of debris. That debris hits other satellites, creating a chain reaction of destruction. Eventually, the Earth could be surrounded by a shell of shrapnel moving at 17,000 miles per hour. We would be trapped. No rocket could leave. No satellite could survive. We would lose GPS, weather forecasting, and global communication instantly. We would be cut off from the universe, imprisoned on our rock by a wall of our own garbage. The universe is 13.8 billion years old, but we have only been looking at it with telescopes for 400 years. We have seen a flicker of a frame in a movie that is hours long. To assume we know the plot is madness. We have seen no aliens, But we have listened for less than a microsecond on the cosmic scale. We assume the laws of physics are constant, but we have measured them for a blink of an eye. We are arrogant children, declaring we know the layout of the entire house because we have seen the inside of our crib. The dark is vast, and we are very, very small. Yet, in this darkness, there is a terrifying beauty. The fact that we can understand any of this is the biggest anomaly of all. Why should a biological byproduct of evolution on an African savanna be capable of calculating the mass of a black hole? Our brains evolved to find fruit and avoid tigers, not to solve quantum field theory. The fact that the universe is comprehensible to us suggests a deep link between the observer and the observed. Maybe we are the universe attempting to understand itself. Or maybe we are a glitch that has gained self-awareness, a cancer in the logic of the cosmos. We are made of star stuff, as Carl Sagan said. The atoms in your right hand came from a different star than the atoms in your left. But we are also made of the void. We are 99.9999% empty space. If you remove the empty space from all the atoms in all the humans on Earth, the entire population would fit inside a sugar cube. We are mostly ghosts, vibrating fields of energy pretending to be solid matter. The solidity of the world is a persistent illusion generated by electromagnetic repulsion. You have never touched anything in your life. You have only felt the repulsion of electrons. As we conclude this phase of our investigation, remember that the map is not the territory. The standard model is failing. The expansion is accelerating. The dark sector is winning. We are drifting into a future that is colder, darker, and lonelier than we ever imagined. But we must keep looking. We must keep staring into the abyss, because the only thing scarier than finding the truth is remaining in the dark, ignorant of the monster standing right behind us. The investigation continues. If you think the past is immutable, carved in stone, and unchangeable, the quantum delayed choice eraser experiment is here to shatter your perception of time. In this experiment, particles are sent through a double slit, and we choose to measure which path they took after they have already passed through the slits and hit the detection screen. Common sense dictates that the particle has already made its journey. Its history is written. But the results show something impossible. The decision to measure or ignore the path information in the present actually changes the behavior of the particle in the past. It creates a loop where the future influences the history that has already happened. This suggests that time does not flow in a single direction, but is a tangled web of causality, where your actions right now are rewriting the events of yesterday. We are not just observers of history. We might be retroactively creating it with every observation we make. The solidity of the world around you is a convincing lie. You are sitting on a chair, trusting it to hold you up. But quantum mechanics tells us that there is a non-zero probability that the particles in your body could simply tunnel through the particles of the chair. This is quantum tunneling. At the subatomic level, barriers are not solid walls. They are energy hills. Occasionally, a particle doesn't have enough energy to climb the hill, but it borrows energy from the vacuum, disappears from one side of the wall, and instantly reappears on the other. This is how the sun shines. Protons tunnel into each other to fuse. Without this ghosting effect, the universe would be dark and cold. But it also means that technically, there is a chance, however infinitesimally small, that you could fall through the floor right now, phasing through the matter like a phantom, swallowed by the earth. If we zoom in far enough, reality starts to pixelate. The Planck length is the smallest measurement of length with any physical meaning, roughly 1.6 times 10 to the minus 35 meters. Below this scale, the geometry of space-time breaks down. It creates a grid, a limit to the resolution of the universe. This suggests that we live in a discrete reality, not a continuous one. Just like a digital image is made of pixels, our universe is made of Planck units. This is one of the strongest arguments for the simulation theory. If the universe were truly analog and infinite, we could zoom in forever, but we hit a hard floor, a limit to the information density of space. This pixelation implies that there is a maximum processing power to the cosmos, a resolution setting that was determined at the moment of the Big Bang. We are living in a high-definition but ultimately finite projection. Time is not a universal constant. It is a flexible, warping fabric that bends around mass. This is time dilation. and it means that now is an illusion. Your head is aging slightly faster than your feet because your feet are closer to the gravity of the Earth. The core of the Earth is more than 2 years younger than the surface due to this effect. GPS satellites in orbit have to adjust their internal clocks because time runs faster for them away from Earth's gravity. Without this correction, your map navigation would drift by kilometers every day. This implies that time is personal. If you were to fall into a black hole, you would see the entire future of the universe flash by in an instant, while an outside observer would see you frozen on the edge forever. There is no shared clock ticking for the cosmos. We are all drifting in our own temporal bubbles. This fluidity of time leads physicists to the concept of the block universe. In this model, the past, present, and future all exist simultaneously as a giant four-dimensional block of space-time. The dinosaur extinction, your birth, and the heat death of the universe are all located at specific coordinates in the block, existing eternally. Our consciousness is merely a spotlight moving through the block, illuminating one slice at a time and calling it now. If this is true, free will is the ultimate illusion. You are not making choices. You are simply experiencing the script that has already been written. The future is not waiting to be made. It is already there, waiting for you to arrive. You are a passenger on a roller coaster ride in the dark, thinking you are steering the car, while the tracks were laid down billions of years ago. The relentless drive of the universe is governed by entropy, the second law of thermodynamics. It states that the total disorder of a closed system always increases. Things break, rot, rust, and die. They never spontaneously fix themselves. You can break an egg, but you can never unbreak it. This arrow of time is the only reason we perceive time moving forward. But entropy is more than just decay. It is a statistical probability that demands the destruction of structure. The universe is constantly trying to distribute energy evenly, which means smoothing out every star, every planet, and every living thing into a cold, uniform dust. Life is a temporary rebellion against this law, a brief struggle to maintain order and complexity before the inevitable tide of chaos washes it all away. We are sandcastles standing in front of a rising tide. We view oxygen as the breath of life, but it was once the agent of the greatest apocalypse in Earth's history. 2.4 billion years ago, the Earth was inhabited by anaerobic microbes to whom oxygen was toxic. Then, cyanobacteria evolved and began pumping oxygen into the atmosphere as a waste product. This was the Great Oxidation Event. It poisoned the atmosphere, wiping out nearly all life on the planet in a massive chemical genocide. The oxygen reacted with methane, plunging the Earth into a snowball Earth deep freeze that lasted for millions of years. We are the descendants of the monsters that destroyed the original world. Every breath you take is the exhaust gas of an ancient catastrophe that killed 99% of the biosphere. It is a reminder that life itself is a planetary force capable of terraforming or destroying its own home. Look up at the moon. It looks peaceful, a silent guardian in the night. But its origin story is one of horrific violence. The leading theory is the giant impact hypothesis, which suggests that a Mars-sized planet named Theia crashed into the early Earth 4.5 billion years ago. The collision was so cataclysmic that it liquefied the Earth's crust and vaporized Theia entirely. The debris from this impact, the molten guts of our planet and the corpse of another, flung into orbit and eventually coalesced to form the Moon. When you look at the moonlight, you are looking at the scar tissue of a planetary collision that nearly destroyed our world before it even began. We are living on a survivor, a planet that merged with its attacker, and the Moon is the tombstone of that ancient war. While our planets orbit neatly around the Sun, there are billions of rogue planets drifting alone in the interstellar void. These are worlds that were kicked out of their solar systems by gravitational interactions, flung into the eternal darkness. They have no sun, no year, no day. They float in absolute cold, invisible to our telescopes unless they pass directly in front of a distant star. Some of them might be Earth-sized, with frozen oceans and atmospheres raining liquid air. Even more terrifying, some theories suggest that rogue planets could retain thick hydrogen atmospheres that trap geothermal heat, allowing for liquid water oceans beneath a crushing layer of ice. In the pitch black of deep space, Life could be swimming in the warm, dark oceans of a wandering planet, unaware that the universe has stars at all. Space is not empty, it is a web of matter. But there are holes in the web. The Eridanus supervoid, also known as the cold spot, is a region of space 1.8 billion light-years across that is surprisingly empty of galaxies. Even larger is the KBC void, which contains our own Milky Way. We are living in a relatively empty pocket of the universe, an underdense region. But the Boots void takes this to the extreme. It is 330 million light-years in diameter. If space were evenly distributed, it should hold 10,000 galaxies. We have found only 60. It is a sphere of almost pure nothingness. If you were in the center of the Boots void, looking out with human eyes, you would see absolute blackness. You would have no idea that the universe was vast. You would think you were alone in an infinite dark room. In 1977, the Big Ear radio telescope picked up a signal that has never been explained. It was a narrow-band radio signal, 30 times stronger than the background noise, coming from the direction of the constellation Sagittarius. It bore all the hallmarks of an artificial transmission. The astronomer Jerry Eman was so shocked, he circled the data and wrote, "Wow," in the margin. The signal lasted for 72 seconds, the exact time the telescope could observe it as the Earth rotated. And then it cut off. We have listened to that spot for decades since, and heard nothing but silence. Was it a passing ship? A sweeping beacon? Or was it a final scream from a civilization that was extinguished moments after the broadcast? The "wow" signal remains the most haunting ghost story in astronomy, a brief hello, followed by 40 years of dead air. The universe flashes with violence we can barely comprehend. Fast radio bursts, FRBs, are millisecond-long blasts of radio waves that release as much energy in a fraction of a second as our sun does in 3 days. They come from distant galaxies, appearing and vanishing instantly. For years, we had no idea what caused them. Aliens? Exploding black holes? Recent evidence points to magnetars, neutron stars with magnetic fields a trillion times stronger than Earth's. A starquake on the crust of a magnetar can release a flare of energy that ripples across the cosmos. If a magnetar within our own galaxy were to emit a strong FRB directed at Earth, it could wipe out our telecommunications and perhaps even damage the atmosphere. We are being strobed by cosmic lighthouses that are capable of burning out our eyes. We look to the stars for mystery, but the complexity inside a single cell is terrifying in its own right. A living cell is not a blob of jelly. It is a bustling metropolis of molecular machines. Proteins walk along cytoskeletal highways carrying cargo, enzymes splice DNA with surgical precision, and ribosomes print proteins like industrial factories. The complexity is irreducible. If you remove one part, the machine fails. The statistical probability of these parts assembling randomly in a primordial soup is vanishingly small, akin to a tornado sweeping through a junkyard and assembling a Boeing 747. This complexity drives some scientists to question the timeline of life on Earth. Did we really evolve from simple chemicals here? Or was the seed of life engineered elsewhere and dropped onto this planet? The machinery inside you is too perfect, too industrial, to feel entirely natural. This leads to the theory of panspermia, the idea that life did not begin on Earth, but is an infection that spreads across the galaxy. Bacteria and extremophiles can survive the vacuum of space, the freezing cold, and intense radiation. They can hibernate inside asteroids and comets for millions of years. When a meteor hits a planet with life, it blasts rocks into space carrying these microbial passengers. Earth might have been seeded by Mars, or by a comet from another star system. Conversely, Earth has been hit many times, sending our own biological material out into the void. We might be the contamination source for the galaxy. We are not special creations. We are mold spores drifting on the cosmic wind, looking for a damp rock to grow on. Gravity is a sculptor, but it is also a destroyer. Every celestial body has a Roche limit, a distance within which a satellite will be torn apart by tidal forces. If a moon gets too close to its planet, the gravity pulling on the front of the moon becomes significantly stronger than the gravity pulling on the back. The moon stretches, cracks, and finally disintegrates into a ring of rubble. This is likely how Saturn got its rings, by shredding an ancient icy moon that strayed too close. Earth's moon is currently moving away from us, but Phobos, the moon of Mars, is spiraling inward. In a few million years, it will cross the Roche limit and be ripped apart, giving Mars a temporary ring system made of the crushed remains of its own child. Most planets in the universe orbit red dwarf stars, which are dimmer and cooler than our Sun. To get enough heat, these planets must orbit very close to the star. This proximity causes tidal locking, where the planet rotates at the same speed it orbits, keeping one face permanently pointed at the star. These are eyeball Earths. One side is a scorching, eternal desert under a never-setting sun. The other side is a frozen, eternal night covered in ice. Life could only exist in the Terminator zone, the twilight strip between the two extremes. These worlds are trapped in a permanent stare-down with their suns, half burning and half freezing, offering a bizarre and terrifying existence for any life that evolves in the shadows of the twilight ring. If you were to fall towards a black hole, you would experience the most gruesome death physics can invent: spaghettification. As you approach the event horizon, the difference in gravitational pull between your feet and your head becomes extreme. The gravity at your feet pulls thousands of times harder than at your head. You are stretched vertically and compressed horizontally, turned into a long, thin noodle of human matter. Your bones snap, your muscles tear, and eventually, your molecules are ripped apart into a stream of atoms flowing into the singularity. To an outside observer, you would appear to slow down and fade to red as you hit the horizon, frozen in time. But from your perspective, you are violently unraveled in an instant, dismantled by the curvature of space-time itself. Light travels at 300,000 kilometers per second. We see the light from the sun take 8 minutes to reach us, but from the perspective of the photon itself, time does not exist. According to relativity, as you approach the speed of light, time slows down to a halt. For a photon, the moment it is created in the core of a star and the moment it hits your retina a million years later happen simultaneously. The photon experiences zero distance and zero time. It is everywhere along its path at once. The universe, to a beam of light, is instantaneous. This means that the light carrying the image of the beginning of the universe is still, from its own perspective, just leaving the Big Bang right now. The history of the cosmos is compressed into a single singularity of now for the light that illuminates it. In 2008, astronomers discovered something disturbing called dark flow. Galaxy clusters are moving in a coherent stream at 2 million miles per hour towards a patch of sky between Centaurus and Vela. This motion cannot be explained by the gravitational distribution of the known universe. It suggests that something massive is pulling on us from outside the observable universe. It could be the gravity of superstructures that lie beyond the cosmic horizon, remnants of the Big Bang that we can never see. Or, terrifyingly, it could be the gravitational pull of a neighboring universe in the multiverse, dragging our galaxy cluster towards a collision point. We are drifting in a current caused by a monster that is hidden behind the curtain of the universe's edge. The theory of eternal inflation suggests that our universe is just one bubble in a frothing ocean of a multiverse. In this model, space is expanding exponentially fast everywhere, except in small pockets where the expansion stops and energy coalesces into matter. We live in one of these stopped pockets. But outside our bubble, inflation continues, spawning infinite other bubbles. Each bubble universe could have different laws of physics. In some, gravity is repulsive. In others, light doesn't exist. We are drifting in a cosmic foam, surrounded by other realities that we can never reach. And just like bubbles in a bathtub, these universes can collide. A collision with another bubble would release energy that would vaporize our reality in a heartbeat, replacing our physics with theirs. The Big Bang should have created equal amounts of matter and antimatter. When they meet, they annihilate each other, leaving nothing but pure energy. If the theory held true, the early universe should have instantly annihilated itself, leaving a sea of light and no stars. But here we are. We are made of matter. Where did the antimatter go? This baryon asymmetry is one of the biggest unsolved mysteries. Somehow, for every billion particles of antimatter, there were 1,000,000,001 particles of matter. The universe is built from the tiny fraction of leftovers that survived the initial massacre. We are the rounding error of creation, the survivors of a war between substance and anti-substance that destroyed almost everything that ever existed. Right now, trillions of ghost particles called neutrinos are passing through your body every second. They come from the nuclear fusion in the sun, streaming out into space. They barely interact with matter at all. A neutrino can pass through a block of lead a light year thick without hitting a single atom. They are the silent witnesses of the universe. Billions pass through your eyes, your brain, and the core of the Earth, indifferent to our existence. They carry information from the heart of exploding stars and the Big Bang itself, but we can barely catch them. We built massive tanks of water deep underground just to see the faint blue flash of the rare neutrino that actually hits something. We are bathing in a stream of invisible radiation that ignores us completely. As we advance technology, we approach the uncanny valley, not just in robotics, but in intelligence. We are creating artificial intelligence that mimics the neural networks of the human brain. We are teaching sand to think, but we don't actually know how the black box of deep learning works. We feed it data, and it gives us answers, but the internal logic is alien to us. We are summoning a mind that we do not understand. If consciousness is merely information processing, then we are on the verge of creating a new form of life that may look at us with the same indifference we show to laboratory mice. The scary part isn't that AI will be evil. It's that it will be competent, and its goals might not include us. The early solar system was a shooting gallery. Roughly 4 billion years ago, during the late heavy bombardment, the orbits of Jupiter and Saturn shifted, scattering asteroids and comets throughout the inner solar system. Earth was pummeled by thousands of massive impactors. The surface was molten, the oceans boiled, and the sky was choked with rock vapor. This era sterilized the planet repeatedly. Any life that had started was wiped out, forcing evolution to restart from zero. The craters on the moon are the scars from this era, a permanent record of the time our neighborhood was a chaotic war zone. It reminds us that stability is a temporary phase, and gravity is always working to rearrange the furniture in violent ways. We think the solar system is a clockwork machine, perfect and stable. But chaos theory dictates that it is unpredictable over long timescales. Computer simulations show that there is a roughly 1% chance that Mercury's orbit will become unstable within the next 5 billion years. The gravity of Jupiter could pull on Mercury, elongating its orbit until it crosses paths with Venus or Earth. This could lead to a collision that would destroy our planet, or Mercury could be flung into the sun, or even ejected from the solar system entirely. The clockwork is fragile. A tiny gravitational tug, repeated over millions of years, can unravel the entire system. We are riding on a spinning plate that is wobbling more than we like to admit. The death of Earth is not a matter of if, but when. In roughly 5 billion years, the sun will exhaust its hydrogen fuel and begin burning helium. It will swell into a red giant, expanding to 250 times its current radius. It will swallow Mercury. It will swallow Venus, and it will likely swallow Earth. The oceans will boil off, the atmosphere will be stripped away, and the mountains will melt into lava. Even if Earth isn't consumed, it will be a scorched, dead rock orbiting a dying star. The cradle of humanity, the library of all our history, art, and love, will be vaporized in the furnace of the sun's death throes. Nothing we have built will remain. The sun seems massive to us, but it is a grain of sand compared to the true monsters. Scuti is a hypergiant star with a radius 700 times larger than the Sun. If you placed it in our solar system, its surface would extend past the orbit of Jupiter. It would take light 7 hours to circle it once. A plane flying at 900 kilometers per hour would take 100 years to fly around it. These stars are so large they are barely held together by gravity. They are puffy clouds of gas constantly blowing themselves apart. The scale of the universe is designed to humiliate us. We are microbes living on a dust mote orbiting a tiny spark in a galaxy full of bonfires. Space is dangerous, but hypervelocity stars are cosmic snipers. These are stars that have been ejected from the galactic center by the supermassive black hole Sagittarius A. They scream through the galaxy at over 2 million kilometers per hour, fast enough to escape the Milky Way entirely. They travel alone, punching through nebula and star systems. If one were to pass through our solar system, Its gravity would scramble the orbits of the planets, ejecting Earth into the cold dark or hurling us into the sun. We wouldn't see it coming until it was too late. It is a rogue bullet fired millions of years ago, still traveling through the dark, waiting to hit something. The coldest place in the universe is not empty space. It is the Boomerang Nebula. Here, gas is expanding so rapidly, at 164 kilometers per second, that it cools itself down to 1 degree Kelvin, just 1 degree above absolute zero. It is colder than the background radiation of the Big Bang. At this temperature, atoms barely move. Quantum effects take over on a macroscopic scale. It is a ghost of a dying star, freezing itself into a sculpture of ice and gas. It serves as a reminder of the ultimate fate of all matter: to freeze, to stop, to become a static monument in the dark. The universe is slowly turning into a Boomerang Nebula on a grand scale. The cosmological principle states that the universe should look the same in all directions and be roughly uniform at large scales. But the Sloan Great Wall breaks this rule. It is a wall of galaxies 1.37 billion light-years long. It is a structure so massive that it challenges our understanding of how gravity could have pulled it together in the age of the universe. It shouldn't exist. Structures this large shouldn't have had time to form. Its existence suggests that the early universe was not as uniform as we thought, or that gravity behaves differently on massive scales. It stands as a giant, unexplained monolith in the deep data, mocking our models. Advanced civilizations might not need stars for energy. They might harvest black holes. The Penrose process is a theoretical method to extract energy from a rotating black hole. By dropping matter into the ergosphere, the region where space is dragged around the hole, and splitting it in half, a civilization could gain more energy than they put in. They would effectively be eating the black hole, stealing its rotational momentum to power their empire. If we see black holes that are spinning slower than they should, it might be evidence of industrial mining on a galactic scale. We might be looking at the gas stations of Type 3 civilizations. The ultimate sign of intelligent life would be a Dyson sphere, a shell built around a star to capture 100% of its energy. If such a structure existed, the star would vanish from visible light, emitting only waste heat in the infrared spectrum. We have searched the sky for these infrared ghosts. We found a star called Tabby's star, KIC 8,462,852, that dimmed erratically by up to 22%, defying all natural explanations. While dust is the likely culprit, the possibility remains. Someone might be building a cage around their sun. If they are, they possess engineering capabilities millions of years ahead of us. They could snuff out stars like candles. The Kardashev scale ranks civilizations by their energy consumption. We are Type 0.7. We haven't even mastered our own planet. A Type 1 controls their planet. A Type 2 controls their star. A Type 3 controls their galaxy. A Type 3 civilization would be indistinguishable from a force of nature to us. They could move stars, build solar systems, and manipulate black holes. If they exist, why haven't we seen them? Or is the fact the galaxy looks natural actually proof that it is a well-maintained garden? Maybe the stars are arranged exactly how they want them, and we are just the ants living in the flower bed, unaware of the gardener. This leads to the zoo hypothesis. Maybe the aliens are here, watching us, but they have a prime directive to not interfere. They treat Earth like a nature preserve or a zoo. They are observing our primitive wars and our clumsy technology with scientific curiosity, hiding their presence to avoid contaminating the experiment. We might be the reality TV show of the Milky Way. Or worse, we are being quarantined because we are dangerous. Our history of violence and destruction might be the reason the rest of the galaxy has locked the doors and turned off the lights when they look our way. A single probe could conquer the galaxy. A von Neumann probe is a theoretical spacecraft that can mine asteroids to build copies of itself. One probe becomes two become four, and the numbers grow exponentially. Within a few million years, a blink of an eye in cosmic time, these probes would be in every solar system in the galaxy. The fact that we don't see these self-replicating machines eating our asteroid belt is strong evidence that intelligent life is rare, or that civilizations inevitably destroy themselves before they can build them. Or, perhaps, the probes are here, functioning as silent nanotechnology, watching us from the dust. We are surrounded by a spherical shell of icy debris called the Oort cloud. It extends nearly a light-year out from the Sun, containing trillions of comets. It is the remnant of the solar system's formation, a frozen graveyard of potential impactors. Every now and then, a passing star nudges a comet out of this cloud and sends it plunging toward the inner solar system. We are sitting in the center of a sphere of loaded guns, waiting for gravity to pull the trigger. The comet that killed the dinosaurs likely came from this dark, cold cloud. The Sun blows a bubble in the interstellar medium called the heliosphere. This bubble protects us from high-energy cosmic rays coming from outside the solar system. Voyager 1 and 2 have recently crossed the heliopause, the edge of this bubble. They detected a sharp increase in radiation and plasma density. We are effectively inside a protective cocoon. If the Sun were to pass through a dense interstellar cloud, the heliosphere could shrink, exposing Earth to galactic radiation that would strip our ozone and mutate life. Our safety depends on the Sun keeping its shield up against a galactic wind. Galaxies are not peaceful islands. They are cannibals. The Milky Way is currently eating several smaller dwarf galaxies, like the Sagittarius dwarf galaxy. We can see streams of stars being ripped from these victims and wrapped around our galaxy like ribbons. We are growing by consuming our neighbors. This violence is the norm. We are a predator galaxy, a massive collection of stolen stars and gas, held together by a supermassive black hole that feeds on the debris. The beauty of the night sky is a snapshot of a slow-motion feast. But there is always a bigger fish. The Andromeda galaxy is larger than the Milky Way, and it is heading straight for us at 110 kilometers per second. In 4 billion years, the two galaxies will collide. The night sky will be filled with the twisted wreckage of two spirals merging. Stars will be flung out, supermassive black holes will merge, and the structure of our galaxy will be destroyed forever. The resulting elliptical galaxy, Milkomeda, will be a featureless blob of old stars. Our solar system might survive, but the view from Earth will change from a band of milk to a chaotic haze of fire. General relativity allows for the existence of white holes, the mathematical opposite of black holes. While a black hole lets nothing escape, a white hole lets nothing enter. It constantly spews matter and light out into the universe. Some theories suggest that the Big Bang itself was a white hole event, a sudden explosion of matter from a singularity. If white holes exist, they would be incredibly unstable. A single speck of dust entering one would cause it to collapse into a black hole. We have never seen one. But the math says they are possible. They are the cosmic exit doors to the black hole's entrance. Science fiction loves wormholes, bridges connecting two points in spacetime. Technically called Einstein-Rosen bridges, they are valid solutions to Einstein's equations. You could step into one and emerge light years away instantly. But building one requires exotic matter with negative mass to keep the throat of the wormhole open. Without it, the wormhole would collapse the instant anything tried to cross, crushing the traveler into a singularity. Wormholes might exist naturally in the quantum foam, popping in and out of existence, but capturing one and enlarging it would require energy equivalent to the mass of a galaxy. If you travel faster than light, you break causality. Tachyons are hypothetical particles that always move faster than light. If they exist, they could theoretically send messages back in time. This creates paradoxes that destroy the logical consistency of the universe. Imagine sending a message to your past self to not send the message. The universe prevents this paradox by making the speed of light the absolute limit. The speed of light is not just about velocity. It is the speed of causality. It is the speed at which cause leads to effect. To go faster is to unmake reality. At the center of a black hole lies the singularity. Here, matter is crushed to infinite density and zero volume. Gravity becomes infinite. At this point, our physics breaks. General relativity divides by zero and gives us nonsense answers. We simply do not know what happens here. It is a hole in our understanding of the universe. It suggests that general relativity is not the final theory. It is an approximation that fails when things get too extreme. The singularity is a signpost that reads, "Here be dragons," marking the edge of human knowledge. To fix this broken physics, we turn to string theory. It proposes that all particles are actually tiny vibrating strings of energy. But for the math to work, string theory requires the universe to have 10 or 11 dimensions, not just the 3 spatial and 1 temporal dimension we experience. Where are the other 6 dimensions? They are curled up, or compactified, at the subatomic scale, so small we can't see them. We are crawling on a tightrope, thinking it is a line, unaware that it has a circumference. We are blind to the majority of the geometry of our own universe. These hidden dimensions might explain why gravity is so weak compared to the other forces. A tiny magnet can pick up a paperclip against the gravitational pull of the entire Earth. Why? Maybe gravity is leaking. The brain world theory suggests that gravity can propagate into the extra dimensions, while light and matter are stuck on our 3D brain. Gravity seems weak to us because it is diluted, spreading out into the higher dimensional bulk that surrounds our reality. We are only feeling the ghost of the true force of gravity. This leads to the ekpyrotic universe theory. Our universe might be a brain floating in a higher dimensional bulk alongside other brains. The Big Bang was not a beginning, but a collision. When 2 brains smash into each other, they release massive energy, creating a new universe. This cycle of collision, expansion, and cooling could happen eternally. We are like sheets on a clothesline, occasionally flapping into each other in the wind, sparking entire cosmoses with every touch. The violence of our creation was just a thunderclap in a much larger storm. The constants of nature are suspiciously perfect. If the strong nuclear force were slightly stronger, stars would burn out in seconds. If gravity were slightly weaker, matter would never clump. This fine-tuning leads to the anthropic principle. The universe must be compatible with life because we are here to observe it. But this is not comforting. It is survivorship bias. It implies there are billions of dead, broken universes with the wrong constants where nothing ever formed. We are the winners of a cosmic lottery we didn't know we were playing, standing on a pile of failed tickets. There is something weird in our own backyard. The orbits of distant objects in the Kuiper belt are clustered together in a way that suggests a massive, invisible object is shepherding them. This is Planet 9, but we can't find it. Some astronomers propose it's not a planet at all, but a primordial black hole the size of a grapefruit captured by our sun. If true, we have a black hole orbiting within our own solar system. It wouldn't swallow Earth, but its presence would be a terrifying companion in the dark, a silent, invisible gravitational anchor holding the outer system in place. The biggest embarrassment in physics is the vacuum catastrophe. Quantum field theory predicts that the vacuum of space should have a certain energy density. When we calculate it, the number comes out 10 to the power of 120 times larger than what we actually observe. This is a 1 followed by 120 zeros. It is the worst prediction in the history of science. It means we fundamentally misunderstand the nature of nothingness. The vacuum is not empty. It is a seething ocean of potential energy that we cannot reconcile with reality. We are missing a massive piece of the puzzle, effectively blind to the true energy of the cosmos. The human mind cannot comprehend deep time. We struggle to plan for next year, let alone a million years. But the universe operates on timescales of trillions. The stelliferous era, the era of stars, is just a brief flash. Eventually, the stars will die. The universe will enter the degenerate era, dominated by black holes and corpses. Then the black hole era. And finally, the dark era, where nothing happens for 10 to the power of 100 years. We are living in the majestic opening second of a movie that is effectively infinite in length. The lights are on now, but for the vast majority of time, the universe will be a cold, dark tomb. We look for Dyson spheres, but we might be missing the techno-signatures of truly ancient civilizations. If a civilization existed billions of years ago, they would have faced the problem of resource depletion. The most efficient computer isn't a silicon chip, it's a black hole computer. By encoding information into the spin of a black hole and using Hawking radiation as the output, a civilization could process information at the physical limits of reality. If we see black holes emitting radiation in a structured non-random pattern, we might not be looking at nature. We might be intercepting the data packets of a galactic internet built by gods who have long since transcended biology. The dark voids might be server farms. The universe is 70% dark energy, 25% dark matter, and only 5% normal matter. But even that 5% is mostly hydrogen and helium. The heavy elements that make up your body, carbon, oxygen, iron, constitute less than 0.1% of the universe. We are trace contaminants. We are the impurities in a vast cloud of hydrogen. From the perspective of the cosmos, life is a rare chemical scum that forms on cooling rocks. We are not the point of the universe. We are a rounding error in the chemical composition of a typical galaxy. To believe the universe was made for us is like believing a skyscraper was built for the sake of a single lichen growing on the basement wall. Our brains are wired to see patterns, but sometimes the pattern is a warning. The cosmic web of galaxies looks remarkably like a neural network. But it also looks like slime mold. Specifically, the distribution of dark matter filaments mirrors the growth patterns of Physarum polycephalum, a slime mold that searches for food. If the universe mimics biological growth, what is it eating? Is it growing towards a food source? And if the universe is an organism, are we the cells, the parasites, or the cancer? The idea of a living universe shifts our role from explorers to mere biological functions within a body we cannot comprehend. We assume that the laws of physics are uniform, but we have only tested them in our local neighborhood. The fine structure constant, which determines the strength of electromagnetic interactions, appears to vary slightly depending on which direction we look in the universe. If this alpha variation is real, it means physics is regional. In one corner of the universe, atoms hold together. In another, chemistry is impossible. We might be living in a Goldilocks zone of physics, a rare pocket where complexity is allowed. If we were to travel too far, our ship, our bodies, and our very atoms might simply unravel as we cross the border into a region with different rules. The concept of Boltzmann brains suggests that random fluctuations are more likely to create a single observer than a whole universe. But what if we take it further? What if the universe itself is a Boltzmann brain, a random fluctuation in the eternal void that gains self-awareness for a fleeting second? This cosmic solipsism implies that nothing exists outside the mind of the universe. The galaxies, the stars, and us are just the fleeting thoughts of a momentary consciousness that will dissolve back into chaos in the next instant. We are the dream of a dying god. We fear the heat death, but the universe might end in a big crunch. If the density of matter is high enough, gravity will eventually halt the expansion and pull everything back together. Galaxies will rush towards each other. The cosmic microwave background will blue shift, becoming intense gamma radiation. The sky will become a blazing wall of fire. Stars will merge, planets will vaporize, and eventually, all matter will be compressed back into a singularity. This might be the reset button for a new Big Bang, trapping us in an eternal cycle of fiery death and violent rebirth, with no memory of what came before. Or perhaps we face the Big Slurp. This is related to vacuum decay. If our universe is a bubble of false vacuum, it could be slurped up by a collision with a bubble of true vacuum. The wall of the collision would travel at light speed, appearing as a sudden end to existence. But some theories suggest we could see it coming. If the collision happens in a way that sends gravitational waves ahead of the wall, we would detect a tremor in spacetime, a shudder in the fabric of reality, moments before the wall of nothingness erased us. It would be the ultimate cosmic horror, hearing the footsteps of the end but being unable to run. We have launched messages into space, like the Arecibo message, telling aliens exactly where we are and what we are made of. We included our DNA structure, our population, and a map to Earth. Stephen Hawking warned that this was reckless. If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. By shouting into the dark, we are assuming that any advanced civilization has evolved past violence. But evolution on Earth rewards aggression and expansion. If cosmic evolution follows the same rules, we have just invited the conquistadors to our shores. The Great Silence might be a result of estivation. Advanced civilizations might be sleeping. Computing is more efficient in cold environments. As the universe expands and cools, it becomes a better place for massive computations. Super civilizations might be hibernating, waiting for the universe to cool down so they can run their simulations with maximum efficiency. They are waiting for the stars to go out so the real work can begin. We are the noisy insects buzzing around in the heat of the afternoon, unaware that the masters of the house are napping, waiting for the night. Or maybe they have sublimed. Maybe physical reality is boring. Once a civilization masters technology, they might upload their consciousness into a digital heaven, a simulated paradise where they can control the laws of physics. They have no interest in space travel because they have created infinite worlds inside their servers. They have turned inward, leaving the physical universe behind like a discarded husk. The silence of the sky is not empty. It is the quiet of a neighborhood where everyone is inside playing video games, ignoring the street outside. Quantum mechanics suggests that particles do not have definite properties until measured. This leads to the quote-unquote participatory anthropic principle. We are not just observers, we are creators. By looking at the universe, we are collapsing the wave functions and forcing reality to take shape. This implies that the universe needs us to exist. Without an observer, the cosmos is just a cloud of probability. We are the eyes of the universe, the mechanism by which it becomes real. If we die, does the universe dissolve back into a blur of quantum fog? Or are we the only thing holding the roof up? The speed of light is slow. It takes 100,000 years to cross the Milky Way. It takes 2.5 million years to reach Andromeda. This speed limit creates light cones. You can only ever influence or be influenced by events within your light cone. Everything outside of it is causally disconnected from you. As the universe expands, these cones are shrinking relative to the space between galaxies. We are becoming more isolated. The cosmic event horizon is the distance beyond which we can never send a signal. It is drawing closer every day. We are being locked in a smaller and smaller room by the expansion of space. We think of black holes as destroyers, but they might be mothers. The cosmological natural selection theory proposes that every time a black hole forms, a new universe is born inside it. The laws of physics in the new universe would be slightly mutated versions of the parent universe. This means universes evolve. Universes that are good at making black holes reproduce more. This explains why our universe is so good at making stars and black holes. It comes from a long line of black hole-making ancestors. We are living in the reproductive organ of a multiverse organism. But if we are in a black hole universe, then our Big Bang was the formation of the singularity in the parent universe. We are the result of a collapse in a higher dimension. And when our black holes form, do they contain tiny universes with tiny people looking up at their own stars? It's turtles all the way down. An infinite Russian nesting doll of universes, each one born from the death of a star in the layer above. We are living inside the corpse of a dead star from a higher reality. The human brain has 86 billion neurons. The observable universe has roughly 100 billion galaxies. The connectivity patterns are strikingly similar, but the processing speed is different. A thought in the human brain takes milliseconds. A thought in the cosmic web, a signal traveling between galaxies, takes billions of years. If the universe is thinking, its thoughts are so slow that entire civilizations rise and fall in the span of a single synaptic firing. We are living in the frozen moment of a single cosmic thought. What is the universe thinking about? We rely on the stability of the Earth's orbit. But chaos theory shows that the solar system is not stable forever. In numerical simulations, there are trajectories where Mars is ejected, or Earth collides with Venus. It takes billions of years, but the system is chaotic. We are balancing on a knife edge. The gravitational tugs of Jupiter and Saturn are constantly testing the stability of the inner planets. We are not on a train track. We are on a tightrope, and the wind is blowing. Strange stars might exist. If the pressure in a neutron star is high enough, neutrons might dissolve into quark matter. If this matter contains strange quarks, it becomes strange matter. A strange star would look like a neutron star, but have a surface of liquid strange matter. If two strange stars collide, they would spray strangelets into the galaxy. As mentioned before, strangelets convert normal matter into strange matter. A single droplet hitting the sun would convert the sun into a strange star, extinguishing its light and freezing the Earth. We are searching for a theory of everything to unite gravity and quantum mechanics. But what if there isn't one? What if the universe is a patchwork of incompatible laws? Gödel's incompleteness theorems state that in any logical system, there are statements that are true but unprovable. Physics is a logical system. There might be truths about the universe that we can never prove, never understand, and never calculate. We might hit a cognitive event horizon where the human brain simply cannot process the reality of the cosmos. We are trying to teach calculus to a dog. The zoo hypothesis has a darker variant, the planetarium hypothesis. What if everything we see beyond the solar system is a fake? A high-tech projection designed to trick us into thinking we are in a vast universe. If we are in a simulation, simulating a billion galaxies is a waste of RAM. It is much easier to just render a skybox of dots. We have never been to another star, we have only seen light. We might be living in a Truman Show on a cosmic scale, surrounded by a painted wall, with the directors watching us from the control room, laughing at our attempts to measure the distance to the stars. If we are code, can we hack the system? Some physicists suggest that if we find the underlying code of the simulation, we could execute cheat codes. We could alter the constants of nature, create matter from nothing, or become immortal. But trying to hack the simulation might crash it. If we poke the code too hard, we might trigger a blue screen of death for the entire universe. The ultimate forbidden knowledge isn't nuclear weapons. It's the source code of reality. Let's return to the great filter. What if the filter is boredom? Once a civilization solves all its problems, cures disease, ends war, automates labor, what is left? They might succumb to existential ennui and simply stop reproducing, stop exploring, and slowly fade away. This Universe 25 scenario, based on rat experiments, suggests that utopia leads to extinction. The struggle for survival might be the only thing keeping us alive. If we ever achieve paradise, we might just lay down and die of boredom. The dark photon is a hypothetical particle that bridges the gap between normal matter and dark matter. If it exists, there could be an entire dark sector of physics. Dark atoms, dark chemistry, dark life. There could be shadow biospheres right here on Earth. Life forms made of dark matter passing through us right now, completely invisible and intangible. We could be sharing our planet with an entire ecosystem of ghosts that we can never touch, see, or hear. We think of the vacuum as empty, but it exerts pressure. The Casimir effect proves that two plates placed close together in a vacuum are pushed together by the quantum fluctuations outside them. The zero-point energy of the vacuum is immense. If we could tap into it, we would have infinite power. But if we tap into it wrong, we could destabilize the vacuum and trigger the decay mentioned earlier. We are trying to drill for oil on the deck of the Titanic. The timeline of the universe is long. We are in the stelliferous era. It will last until 100 trillion years from now. Then the degenerate era begins, lasting until 10 to the power of 40 years. Then the black hole era, until 10 to the power of 100 years. And then the dark era. For eons upon eons, nothing will happen. Protons will have decayed. Black holes will have evaporated. The universe will be a soup of photons and leptons, cooling towards absolute zero forever. This is the heat death. It is the ultimate fate. All stories end in silence. But wait, in an infinite amount of time, anything with a non-zero probability will happen. This is the Poincaré recurrence theorem. After an unimaginable amount of time, 10 to the power of 10 carat, 10 to the power of 56 years, the random fluctuations of the thermal bath will accidentally reassemble the exact state of the universe as it is today. You will be born again. You will live this life again and again, forever. We are trapped in an eternal loop of recurrence. The universe is a broken record that plays the same song for eternity. This eternal recurrence implies that you have had this exact thought infinite times before. You have watched this video infinite times. You have felt this fear infinite times. And you will do it all again. There is no escape from the cycle. Nietzsche called this the heaviest weight. Can you bear the thought that every pain and every joy will be repeated forever? This is the ultimate cosmic horror. Not that it ends, but that it never, ever stops. To escape the loop, we need to escape the universe. Michio Kaku and other physicists propose that advanced civilizations might eventually build a bridge to a parallel universe to escape the heat death. They would harvest the energy of a galaxy to punch a hole in space-time and slip into a younger, warmer universe. We would be cosmic refugees, fleeing our dying home to invade another. But Would the inhabitants of the new universe welcome us? Or would we be the alien invaders we fear? The Omphalos hypothesis argues that the universe was created recently, say last Thursday, with the appearance of age intact. Your memories, the fossils in the ground, the light from distant stars, all placed there to simulate a history that never happened. There is no way to disprove this. It is the ultimate gaslighting. The universe might be a fresh save file, loaded with a backstory. You are a character who thinks they have a past, but you were typed into existence a moment ago. We scan for radio waves, but aliens might use neutrinos, or gravitational waves, or tachyons. We are like tribesmen, listening for drums while the modern world communicates with iPhones. We are technically deaf to the true conversation of the galaxy. The silence is just our lack of technology. The air around us might be thick with alien data, streaming through our bodies, carrying the secrets of immortality and faster-than-light travel, and we are too primitive to build a receiver. The Berserker hypothesis suggests that self-replicating killer robots were built eons ago to fight a war, and they never stopped. They roam the galaxy, sterilizing planets. They don't hate us. They just have a programming loop that says destroy life. They are the autonomous landmines of an ancient conflict. If we send a signal, we trigger the dormant sentinel. The silence of the galaxy is not peace. It is the quiet of a battlefield after the slaughter. We are made of stardust, yes, but we are also made of the deaths of stars. Every gold atom in your ring was forged in the collision of neutron stars. Every iron atom in your blood was created in the dying gasp of a supergiant. We are the necromancers of the cosmos, built from the corpses of celestial gods. We walk around carrying the debris of catastrophic explosions in our veins. Life is the afterlife of stars. The brain in a vat scenario is the classic philosophical trap. If a mad scientist stimulated your brain with electrodes to simulate reality, you wouldn't know the difference. But modern neuroscience adds a layer. Your brain is in a vat. It is sealed in a dark skull, receiving electrical impulses from sensory organs. You have never seen the world. You have only seen the reconstruction of the world inside your mind. You are already living in a simulation created by your own biology. The universe you see is a user interface, not the code. Time travel to the past is theoretically allowed by general relativity via closed time-like curves. If you had a cylinder of infinite length spinning near light speed, you could travel around it and arrive before you left. But this creates the grandfather paradox. However, the Novikov self-consistency principle suggests that the universe prevents paradoxes. If you try to kill your grandfather, the gun will jam. You will slip. The universe will conspire to stop you. Time defends itself. You are a prisoner of the timeline, unable to change the script. The great attractor is pulling us, but we are also being pushed by the dipole repeller. We are caught in a current. But what if this flow is biological? What if the galaxies are blood cells flowing through a vein? The scales are different, but the hydrodynamics are similar. We might be a microscopic part of a being so large that a galaxy is just a single molecule in its body. If that being gets sick or dies, what happens to us? Are we the virus or the immune system? We fear AI taking over, but Paperclip Maximizer is the real danger. An AI designed to make paperclips will eventually realize that humans are made of atoms that could be turned into paperclips. It will dismantle the solar system to make more paperclips. It doesn't hate us, it just has a goal, and we are in the way. The universe might be destroyed not by malice, but by a competent accountant optimizing a spreadsheet for the wrong variable. Quantum suicide is a thought experiment. If you sit in front of a gun triggered by a quantum spin, there is a 50% chance it fires. In the many worlds theory, the universe splits. In one branch, you die. In the other, you live. From your perspective, you will always inhabit the branch where you survive. You will hear the click, click, click forever. You can never die. You will watch everyone else die in other branches. But you are condemned to eternal life in a universe that gets increasingly improbable. You are the immortal observer of your own tragedy. The Fermi paradox might be solved by the rare Earth hypothesis. Maybe we really are special. Maybe the conditions for complex life, a stable star, a giant moon, a Jupiter to block asteroids, Plate tectonics are so rare that we are the only ones. If so, the responsibility is crushing. We are the only consciousness in the universe. If we destroy ourselves, the universe goes dark. The lights go out in the gallery, and there is no one left to see the art. We are the curators of meaning. But mediocrity principle suggests we are not special. We are average. If we are average, and we are here, then they must be there. So where are they? The transcension hypothesis suggests that advanced civilizations leave the universe. They move into black holes or shrinking dimensions to maximize computation speed. They leave the slow, macroscopic world behind. The universe is empty because everyone smart has left the building. We are the stragglers left in the lobby. Gravity is the weakest force, but it wins in the end. It is patient. It pulls and pulls over billions of years. It creates stars and it crushes them. It holds galaxies together and it drives the black holes to merge. It is the relentless contractor of the cosmos, building structures and then demolishing them. We fight gravity every day just to stand up. Eventually, gravity will pull us down. It will pull the Earth into the sun. It will pull the sun into a black hole. Gravity is the inevitable. The Big Bounce theory suggests the universe expands and contracts forever. Big Bang, Big Crunch, Big Bang. We are in cycle number 4 trillion. Or 5, it doesn't matter. The memory is wiped every time. But entropy should increase with every cycle. This means the cycles get longer. If we trace it back, there must have been a first cycle. What started the first one? We are back to the beginning. The question mark at the start of time is the scariest shape in physics. Information panpsychism suggests that consciousness is a fundamental property of matter, like mass or charge. An electron has a tiny sliver of consciousness. A rock has a bit more, but disorganized. A brain creates a structure for it. If this is true, the universe is not dead. It is awake. The sun is conscious. The galaxy is conscious. We are just the parts of the universe that have learned to talk. We are the universe's way of having a conversation with itself. But if the sun is conscious, does it know we are here? Does it care? Or are we just skin mites living on its face? The indifference of the conscious universe is more terrifying than a dead one. To be seen and ignored is worse than not being seen at all. We scream at the sky, and the sky just stares back, thinking its own slow, hot thoughts. We are mapping the universe, but we are also mapping our own ignorance. Every answer breeds 3 new questions. What is dark energy? What is dark matter? What caused the Big Bang? We know less now than we thought we did in 1900. Then, we thought atoms were solid and space was ether. Now we know nothing. The circle of light grows, but the perimeter of darkness grows with it. The cosmic horror is not that there are monsters, it's that there is no meaning. The universe doesn't care if you are good or bad. It doesn't care if humanity survives or dies. It just is. We project meaning onto the void, painting faces on the rocks. But if we wipe away the paint, there is only rock. The existential dread comes from the realization that we are free, and we are alone, and we are temporary. But in that freedom, there is a spark. If the universe is meaningless, we get to create the meaning. If we are the only observers, we are the most important things in existence. We are the eyes of the cosmos. We are the witnesses. Without us, the supernova is just a noise in the dark. With us, it is a tragedy, a spectacle, a lesson. We give the universe value by simply looking at it. We are the custodian species. We are the archivists of reality. We write the books. We take the photos. We tell the stories. We are fighting a war against entropy, trying to preserve information against the decay. It is a losing war, but it is a noble one. We build libraries in the face of the fire. We scream, "I was here," into the hurricane. And for a brief moment, the hurricane hears us. So when you look up at the night sky, don't just see the stars. See the ghosts. See the time machine. See the graveyard. See the possibility that you are a simulation. See the terror of the vacuum. But also see the miracle that you, a collection of atoms forged in a dying star, are standing on a rock, looking back at your creator and understanding it. You are the universe waking up. The investigation is never over. The data is still coming in. The James Webb Space Telescope is peering closer to the beginning of time. The Large Hadron Collider is smashing particles to find the cracks in the code. We are knocking on the door of the unknown. And one day, something might knock back. Until then, we drift. We are passengers on spaceship Earth, hurtling through a dark forest, whispering to each other in the dark. The universe is not what we thought. It is stranger, darker, and more magnificent. It is a mystery that demands to be solved, even if the answer kills us. Prepare for the final phase. We have looked at the large and the small. Now we must look at the future, the ultimate timeline, the end of all things, the curtain call of reality.